a variety of parts used by automotive, lawn and garden, recreation, hydraulics, and agricultural markets. When designing powder metal components, it's often asked, what are the size limitations? The size limitations are dictated by the equipment more than geometry. However, there is a very important concept at work here, and it's called aspect ratio. And if you look at this graphic, we see in the bottom left a 1-to-1 aspect ratio. That is a 1-inch diameter by 1-inch tall component. If we apply 35 tons per square inch to a typical iron powder, we'll achieve around a 6.95 gram per cubic centimeter density. If we take the same 1-inch diameter and make that 6 inches tall, we have a 6-to-1 aspect ratio. If we apply 35 tons per square inch to that component, we can achieve a 6.7 grams per cubic centimeter density. And what we end up with is a density divide or density split called a neutral axis, approximately right in the middle of that column. And this assumes that we compact this from both ends. That neutral axis is important to understand because it is, in fact, lower density than the ends of the component. If we go to the middle example, we see an aspect ratio of approximately 12-to-1. At a 12-to-1 aspect ratio, the neutral axis can be very pronounced. And since density is so important to the mechanical properties of powder metallurgy, if you design a part that has a very, very high aspect ratio, either in itself or in some of the walls, i.e. the skirt or flange of a component in the direction of pressing, you'll get a wide variation in properties in that component. And it's not a problem to make it if you understand the implications. So it's important that we understand this concept of aspect ratio. When we look at the basic conventional PM process, we start with metal powders. Those metal powders are blended or mixed together with lubricants and other alloying ingredients. From there, the press-ready mix goes to the compacting process, where the powder is consolidated in a closed die and formed to the prescribed density. After compacting, the components are then transported through the sintering furnace, where strong metallurgical bonds are formed between the powder particles. And in many cases, parts are finished and ready for consumption, shipped to the customer at this point in the process. Most of the powder that's used in the conventional powder metallurgy industry is produced from water atomized material, where high quality metals are melted and then poured through a tundish and hit with high pressure water and atomized. This graphic shows the flow of water atomization. We start with high quality scrap iron in this case. The iron is melted and then poured into a ladle, and from the ladle it's poured into a tundish. Through the tundish, the material then flows into the atomization area, where high pressure water converts the molten metal into a powdered material. After the material is atomized, it goes through a dewatering process, and then the black powder is stored in bins. From those bins, the material goes into the annealing furnace, where it is annealed in a protective atmosphere to remove the oxidation that's introduced during the water atomization process. After annealing, the powder cakes are then pulverized and crushed and subsequently screened and packed out ready for shipment. Powder is prepared for production through a process of blending and mixing. Elemental or partially alloyed or pre-alloyed metal powders are mixed with lubricants and other alloying materials, such as copper, nickel, graphites, and lubricants for compacting. In the blending process is a thorough intermingling of powders of the same nominal composition, such as two different types of iron powder. Mixing is the thorough intermingling of powders of two or more materials, such as iron and copper, or iron and nickel. After mixing, the powder is then brought to the compacting press. I'm going to talk about how mechanical properties are developed in powder metallurgy. And number one is the number, size, and shape of the voids, or the density. The density of a part is the weight per unit volume. And density largely determines a lot about the properties of a powder metal component. Here you can see the compacting process, where the powder is carried over the die cavity with the feed chute. The upper punch then closes off the die and molds or forms the component in the closed die. In this case, we have an upper punch, which is now entering. We have the lower punch, which is stationary, and the die in red, which is movable. The upper punch closes off the die after filling the cavity. The lower punch remains stationary. The die travels down. This process is known as withdrawal type compaction, and you can see the green component that's formed. Compaction establishes the density of the powder metal compact. In this graphic, you can see a powder particle, and you can see the deformation that occurs in compaction. So what's really happening in the compacting process? As we increase density, we're decreasing porosity. And what we see here is an increasing in the area of contact between powder particles due to particle deformation in compaction. In this graphic, we see the part was pressed to a fairly low density of 6.7 grams per cubic centimeter density. And we increased that density to approximately 7.0. And to the far right, we have increased the density to 7.2 grams per cc. And what you can see in the yellow oval is the fracture surface. This is where the powder particles were in contact with each other. And we are looking at the area of contact between powder particles that has been sintered together. The fracture surface that we're looking at represents that area of contact. And you can see as the density increases, we can see the increasing area of contact. And this is the effect of density on the mechanical properties in powder metallurgy. So the second part of the mechanical properties triangle is developed in the sintering process. So after parts are compacted, they're taken to the sintering process and put into the loading zone of the furnace. This is a continuous mesh belt sintering furnace. And the lubricant that was used to facilitate compaction will be removed in the delube zone at approximately 1350 degrees F in a protective atmosphere. After the delubing, the parts enter the high heat zone where they're sintered at 2050 to 2100 degrees F. Sintering is the formation of strong metallurgical bonds between the powder particles that have been consolidated in compaction. Then we go through a transition zone where the sintered compact is stabilized, and then into a cooling zone. After the parts exit the cooling zone, they come to an unloading area, and the parts are then unloaded and staged for the next step in the PM process. During the sintering, we see the particle-to-particle welding, or the sinter necks that are formed. This is where we're actually welding those powder particles together. Here you can see the effect of density on mechanical properties. Across the bottom, we see density, and on the Y scale, we see tensile strength. And you can see the lockstep agreement between density and tensile strength. In some cases, we require very high strength components and or parts with very good wear properties. So we increase strength and improve wear by going through a quench and temper process. The tempered martensite is a result. Here we see the low carbon condition of iron called ferrite in the microstructure. In the middle slide, we see the addition of carbon or graphite, combined carbon, to produce a pearlitic or pearlite microstructure. And in the far right, we see a martensitic high carbon form of iron. And you can see under each slide is the yield strength. The ferrite is 29,000 psi yield strength, approximately. The pearlite produces approximately 53,000 psi yield strength, and the martensitic microstructure produces 85,000 psi yield strength. These materials are all processed at the same density, but just produce different microstructures. And you can see how the properties improve. Compaction develops the area of the particle-to-particle bond. Sintering welds the powder particles together, and the alloy composition and heat treatment determine the strength of the particles. Let's take a look at some PM applications. Here we have a notch and pocket plate that are used in one-way clutches in automotive transmissions. They're made from sinter-hardened steel and iron carbon steel. Here we have an automotive planetary carrier system, and you see a number of PM components here. They're pressed and sintered and then sinter brazed to form the carriers, and the gears are powder metal forged material. Here we see stator cores for electric motors made from soft magnetic composite insulated iron particles. The rotor core for a hybrid electric motor is made from sintered soft magnetic outer rim and sinter bonded to a copper steel inner hub. Powder metallurgy is a global commercial business and highly studied science. Conventional PM offers cost-effective solutions for high tolerance applications. If you want to learn more about powder metallurgy, visit picpm.com.
Okay, this is the
video calls
regarding the process of sintering, as we discussed earlier regarding basics of powder metallurgy, where we discuss atomization, chemical method, and electrolyte. Okay, these are the basic three methods that we were discussed in the previous lecture. And initially, before that, how and which kind of what kind of process are there, and what kind of properties we can achieve with the help of powder metallurgy, that we were discussed. This is a basic and generalized method to produce powder, that is pressing, sintering, and three principal methods by which metallic powder are commercially produced, that is atomization, chemical, and electrolyte, where we were discussed the atomization process, and we just see the video of that also. And we know that this figure is very important when we have to produce a one-dimensional, two-dimensional, or three-dimensional powder. Now, this is a basic sequence, as we discussed earlier, about production of powder. That blending is there, compacting is there, and sintering is there. We know that what is blending, but I repeat once again. Already I discussed in the previous lecture. As blending is powder of same chemistry but possibly different particle size are intermesh with each other. Means what happened here, different particle size are often blended to reduce the porosity. For successful result in the compactness and sintering, the starting powder must be homogeneous. We know that whenever we produce any powder, any material, any product with the help of powder metallurgy, then we require some homogeneous uh, atom arrangement. Means it look like a smooth arrangement. For that, what we have to do, we have to prepare that same chemistry, it means same properties are gathered together, met together, and they may mesh with each other, and then we are produce the blending, and we are producing the powder, which may definitely, if we are produced with the help of this way, then definitely the porosity may reduce. We know that if the porosity is increased, then definitely it may be failure on that time. So it is very important when we talk about the powder metallurgy and when the blending process is there to reduce the porosity, mixing powder of different chemistries are combined. Powder metallurgy technology allow mixing various metals into alloys that would be difficult or impossible to produce by other means. Okay, why we are prefer for the powder metallurgy? This is given in this one statement that most probably some kind of property if you have to achieve, then which is not possible with the help of a different kind of uh, any process. So on that time, what we have to we have sometime it may be costly. The powder metallurgy sometime it may be costly, but we have to follow this process because whatever or whichever the properties we have to achieve, that achieve with the help of only powder metallurgy. Okay, so on that time we definitely go for the powder metallurgy. Blending a coarse fraction with a finer fraction ensure that the interstices between large particle will be filled out. Means coarser fraction means it may be near to each other. Okay, so what happened with the help of blending? It the particles are come near to each other. Powder of different metals and other material may be mixed in order to impart special physical and mechanical properties through metallic alloying. Lubricants may be mixed to improve the powder's flow characteristic. Okay, every time it's not necessary that we have to use the powder, sorry, lubricant to produce the powder, but sometimes it may be necessary that we can prefer to use the lubricant for better flow of the different kind of small particles. Okay, so it may be when it may become with together. Definitely, if there is good lubricant, then it may not require that much time to go near, and we definitely reduce some porosity. Okay, so on that time, lubricant is also taking good part when we start to do the blending or mixing. Binders such as wax or a thermoplastic polymer are added to improve the green strength. Okay, so this is another word for you, that is green strength. So there is minor difference between green strength and strength. So you just remember that when it may be in the initial condition when we will start to produce the powder. So on that time, whatever the strength we are achieved is called as a green strength. Now blending to make a homogeneous mass with uniform distribution of particle size and composition. This is very important point. As you know that whenever I prepare any shaft or whenever I prepare any kind of gear with the help of a powder metallurgy, on that time homogeneous distribution means each and every time it may be distributed in proper way. हर एक जगह पर properly uniformly each and every particle should be managed. अगर if it may not possible, अगर वो नहीं होता है, then definitely it may be raise the porosity, it may fail at the time of birth. So on that time blending is very important point at after mixing or mixing process to make a homogeneous with uniform distribution of particle size and composition. Powder made by different process at different sizes and shapes that we know. Mixing powder of different metals combined in general carried out air or inert gases to avoid oxidation. What we have to do, we can flow the air or inert gases, liquid for better mixing, eliminate of dust and reduce the explosion hazard. Okay, why we have prefer liquid? Because sometimes if air is there, then what happen? Definitely explosion is there. So we have to reduce, if you want to reduce the uh, explosion, then we prefer the liquid also. And definitely due to the liquid, the flow is very proper way, and we are binding the particle in very proper way. So as per the nature of the powder, we will proceed for selection, different kind of selection of the process. Either we have to go with the air or we have to go with the liquid. Bowl geometries for blending powders. See, this is some basic figure given to you. You just I just trying to give it to you with the proper 3D image, so it's very easy for you to understand that what kind of component we are used to uh, produce the powder with the help of blending. some common equipment geometry used for blending powder, like cylindrical rotating cube is there, double cone is there, and twin shell is there. As you can see with different color, so it's very easy for you. And there is one blending metal powder mixture is given to you. So with the help of this kind of machine, blending machine, uh, we are start to blend the powder as per our requirement. Compaction. First line is very important. Application of high pressure to the powder to form them into the required shape. Okay, whichever shape I want, and that shape, how can I carry? Definitely for require, I require some enough pressure. So that pressure is called as a compaction. So conventional compaction method is pressing, in which opposing punches squeeze the powder contained in a die. This word give you the proper word that opposing punches, two punches are in the vertical condition, and they may come near to each other. So due to that, what happened? Whatever this whatever the space between that, it may be reduced, and whatever the pressure they want to achieve, that can be achieved with the help of the compaction process. To work part after pressing is called green compact. You just remember the word. To work after pressing is called green compact. The word green meaning not yet fully processed. Okay, I already discussed that the green strength and strength. Green strength means initially whatever we are achieve the strength, it is called as a green strength. But after end of the process, whatever we are achieve the strength, it is called as a strength. Okay, so green compact means initially whatever we are compacting, it is called as a green compact. The green strength of the part when processed press is adequate for handling but far less than after sintering. Okay, after sintering the strength may be reduced. Press powder into the desired shape and size in dies using a hydraulic or mechanical press. Okay, कैसे प्रेस करेंगे उसके? So we have to use either mechanical press or either it may be the hydraulic press. Okay, so that depends on the application and depends on the pressure which we have to require the properties. Based on the our properties, if we require the good compression property, then we prefer the mechanical press also. So press powder into the desired shapes and size in dies using a hydraulic or mechanical press. Press powder is known as a green compact. Stages of metal powder compaction. Now कैसे करेंगे? So there are some basic steps. As you can, it's a very easy to see in the diagram, the compaction process. Powder do not flow like they simply compress until an equal and opposing force is created. कब तक flow होगा? जब तक equal and opposite force लगेंगे तब तक. Okay, you can see in the first figure that after that initially before pressing, when we start the pressing and after pressing, so we will easily compare all three figure, and we can just see that the porosity is definitely reduced with the help of compacting process. These opposite forces is created from the combination of resistance by the bottom punch, friction between the particle and die surface, friction between the particle. Definitely the friction between the particle is there. So friction between the particles and die surface. Compacting, consolidate and densifies the components for transportation to the sintering furnace. Compacting consists of automatically feeding a controlled amount of mixed powder into the precision die. Compacting, I repeat, compacting consists of क्या करता है वो? automatically feeding a controlled amount of mixed powder into a precision die, and after which it is compacted, means pressed. You just see the pressing cycle of powder metallurgy, where adding metal powder initially from this way. After adding the powder, it may be filled in this vertical line, and then with the help of press in both the side, we are just pressing the metal powder, and initially we just create the pressure, so it is called as injecting the compact, then pushing, compacting and recycling. Okay, so once again we push it, and we start the recycling. Compacting is usually performed at room temperature, so not require that much temperature. Pressure range from, this is very important whenever question may be asked in your exam regarding define compacting process. On that time you may just refer and mention the range of the pressure, so it's very clear in the examiner that you know the basic process, and definitely you have to draw the basic figures. Compacting is usually performed at a room temperature. Pressure range from 10 ton per square inch, 138 megapascal to 827 megapascal. Okay, so the range is you can achieve up to 827 megapascal. So it's a good pressure we are achieve in compacting process. This is one basic figure given to you, there typical press where a compacting process is done. A removal die set, पूरा die set दिया हुआ है, it is in the right side. Allow the machine to be produce parts with one die set while another is being fit to produce a second product. Okay, so this is the basic method, basic machine to prepare the to with the help of compacting process to prepare the metal powder. Now, as we know that compaction process initially in the previous slide, that basic steps to produce the powder is given in this figure, but sometime it's a generalized process, but we if we follow the steps, then these are the basic steps for compactions. Initially definitely we start this cycle, then charging die with powder, means we fill the powder on in the die. After that we just try to pressing, on that time वो जो feed shoe है it may be removed from that place, so we are not get any kind of resistance, so compactness start, and it may be completed. After that we eject it and then recharge. So on that, and this way, this is a basic and fundamental steps to do the compactness. Now थोड़ा डीप में जा रहे हैं. Friction problem in cold compactness. Sometimes suppose when we start to do the cold compactness, means when the temperature is reduced or when the temperature is at room temperature. Okay, so on that time what happen? Friction is definitely there. Okay, so what kind of effect are produced due to friction? Okay, that we are now discuss. You can just see the figure where punch is given to you, fixed container is there, and we produce ejector process also, and we try to get to achieve the our powder as per our point of view. So you have to remember that in many time already we ensure that a cold process is, but if the process is cold, then between the punch and the surface of the die there is some friction, so it may be reduce the pressure. So on that time we have to take it care that when we are start the process on room temperature, on that time we will also conclude the also calculate the pressure of that friction of that process, and based on that we will give the proper pressure. Okay, definitely we have just discussed that up to 857 megapascal we will use the pressure in the compacting. So based on that we are calculate, and we just calculate the friction, and based on that we are clear the compacting process. Okay, so up to this we are just discuss about the compacting process of powder metallurgy.